Hi folks, welcome back to Integrals Review for Math 151. In this video, we'll take a look at some definite and indefinite integrals just to practice the process and highlight a few techniques that I think will be really useful as we move forward in Math 151. So let's get started with example number 3. So in this example, we have the integral of the square root of x minus 1 over the square root of x dx. Now that's going to be something that we definitely want to rewrite with our powers. So we would write it as the integral of x to the power of 1/2 instead of the square root of x minus 1 over x to the 1/2 dx. Now what we can do with the power on the bottom is we can rewrite that second term as x to the negative 1/2 because it's x to the 1/2 but it's on the denominator of the fraction. Okay, so now that we have this rewritten in the powers, now we can go ahead and use our power rule. Okay, so the power rule says that we are going to, here, let's go ahead and write this down over here. So our power rule for integrals says that if we integrate x to some power, we'll call that power n, the formula we can use is 1 over n plus 1 x to the n plus 1, and if it is an indefinite integral, we need to have that plus c at the end. Okay? So the one exception to this, and I want to make a big point of this, the one exception is that n cannot equal -1, okay? If n equals -1, or the power equals -1, then the integral is going to be the natural log, meaning if you have the integral of 1 over x dx, that's going to be the natural log of x plus c. All right, so that being said, let's go ahead and apply the power rule to our problem. So if I plug in 1/2 for n, the integral of the first part will give me 1 over 1/2 plus 1, x to the 1/2 plus 1. And then the second part will be minus 1 over -1/2 plus 1, x to the -1/2 plus 1, and don't forget that plus c. All right, what's this going to give us? The power for the first term is going to be x to the 3/2, and that means that the coefficient is the reciprocal of that, 2/3. Minus the power for the x here is going to be 1/2, and the reciprocal of that is 2. Now, I do want to take the time to rewrite this as in radical notation, so without a fractional exponent, okay? So we'll get 2/3 the square root of x cubed minus 2 times the square root of x plus c. All right, that ability to go back and forth between the rational form, which the fractions in the exponent, and the radical form with the square root thing is really, really important, and that's a skill I want us to be very solid on. Okay? All right, let's move on to example number 4. Example number 4 says the integral of dx over 2x. Now again, I think rewriting is really helpful, so I'm going to rewrite this as the integral of 1 over 2x dx. Okay, that looks more like a regular integral. And I'm even going to break up this into two fractions, 1/2 times 1 over x dx. When I break it up like that, I can tell that I have a constant. Whoa! I can tell that I have a constant, and I'm going to bring that constant out to the front. So really, I have 1/2 the integral of 1 over x dx. Okay? Now, we just talked about the power rule, and we talked about the exception to the power rule, that if n equals -1, we're actually going to have a natural log instead, okay? So let's see what happens if we forgot that rule. What if we forgot it and we just tried to use the power rule. Well, then we'd probably do this. 1/2 the integral of x to the negative 1 dx. And then we would use our power rule, and we get 1/2 times 1 over negative 1 plus 1, x to the negative 1 plus 1, plus c. And then we'd get 1/2 1 over 0, x to the 0 plus c. Now that is very, very problematic. And by that, I mean that 0 in the denominator, okay? So when we get here, it becomes undefined and we can't go any further. So that's why we cannot use the power rule. Instead, we really have to recognize that when we see this 1 over x dx, that integral, that we have to automatically think natural log, okay? So let's put an x through this so we know not to use that. And let's bring the correct answer over here. And we get equals 1/2 natural log. And let's make sure that we put in the absolute value, okay? I forgot to put that in before, but it is natural log of the absolute value of x, because we want to make sure that the number we put in is in the domain of our function. So 1/2 natural log of the absolute value of x, and don't forget, whoops, your plus c here. And that is our answer for number 4. Okay. All right, let's move on to example number 5. So, with example number 5, I think this is a really good reminder that no matter what strategies we learn, power rule, u substitution, and all the ones that we're gonna learn, the first thing we should always try and do is see, can we simplify things algebraically, okay? And when we have one term in the denominator, like we do here, x squared, it's actually a really good sign that maybe we can simplify this before we start. So I'm going to split this into 2 fractions. The integral of x over x squared, so that's the first term, minus 1 over x squared dx, okay? So that's a really helpful trick to use with not just integrals, but simplifying in general. If it's in one fraction, you can often split it into more than one fraction, okay? Now, let's simplify even more. The integral of, let's see, x divided by x squared reduces to 1 over x minus 1 over x squared dx. Now, here's why I chose this problem, okay? We just saw in example 4 that we can't use the power rule when we have 1 over x. But we also saw in example 3 that with any other power, we should use the power rule, okay? So sometimes that happens together in the same problem. So this one is not power rule, okay? And this one is power rule. All right, so 1 over x is not going to require me to use the power rule, but 1 over x squared will require me to use the power rule. So what I'm going to do is I'm going to rewrite this one more time as the integral. I'm going to keep the 1 over x because I know I don't need to rewrite it to see the power because I'm not using the power rule. But the second term, I'm going to write as x to the minus 2. Because the power rule only works if x is not in the denominator, okay? All right, now that we have it like this, we can see that we're going to use the natural log for this one, okay? And then we're going to use the power rule for the second term. So that's going to give us natural log of the absolute value of x minus, let's use the power rule, 1 over negative 2 plus 1, x to the negative 2 plus 1. Don't forget the plus c. All right, let's clean this up. Natural log of absolute value of x minus negative x to the negative 1 plus c equals natural log of x plus 1 over x plus c. Okay? So this problem, I think, is really good in terms of summarizing a lot of the different skills that we need to know. We need to use, or we need to be able to use more than one rule in the same problem, and a lot of our foundational algebra skills as well. Okay? So let's go ahead and stop here for this video. Come on back for some practice with definite integrals, where we practice plugging in those bounds again and also reviewing a little bit of trig. All right, I'll see you there.